Okay, so I hope everyone can see my screen.
Yeah.
Okay, thank you. So the first question is, it's binary tree level order traversal 2. So the last time which we did, we have traversed the binary tree from top to bottom, and we need to return the children at every level. Now we need to uh, now we need to do on the reverse basis. So similarly, level order, but in a reverse way. Anyone has tried this particular problem?
I I did it as similar like last time. Do the level order traversal top down, and once I
Yeah.
got the array result, then I
Mm-hmm.
reverse it.
Yeah, that's one approach. Even I think about that only, like just do the level order like top down, like how we did last time, and just reverse the list. Anyone has any other idea? That's a nice approach, I would say.
We can also do the depth first
Queue.
search.
Yeah, using a
Okay.
queue.
Queue with the depth first search?
The recursive method is the depth first search, right?
Yeah, yeah. So someone is saying we can use the depth first search. How?
Okay, okay. I did using the recursive way.
Oh, yeah. So how you have done that?
I think this was similar to what we discussed, the binary level or the traversal one, where you
Yes.
just recurse the right node for a left node and the right post order traversal basically, and then add it to your result list.
Yes. And now we just need to do it in reverse manner.
Yeah, I think post order traversal, the previous case we did level order.
Yeah.
I mean in order, and in this case we'll do the post order traversal.
Okay. Post order using, post order
Just
using a
recursion.
recursion.
Yeah.
So you are just appending that in a list, whatever you are getting.
Yes. Yeah. Every level you have a new list.
Yes.
And then you add it to your main resultant list.
You have done that. Can you share the code or something if anyone wants to see it?
I am on my phone. I can share it later, or if someone else has coded.
Okay, anyone wants to go with another other? Thank you so much, Smita. That's
Sure.
one approach. So anyone wants to discuss? Yeah.
I was thinking if this can be solved using queue as well. I haven't solved this, but it just came to my mind.
Okay, for queue,
Like the
I think
BFS.
for queue, what I would do, like while traversing each level, I'll just append in the like first position, like how we are appending at the last position. We
Right.
just starting appending in a result list or a main list at a starting position each level. So while we reach at the end of the level, we can that level would be at the first in our result list.
Okay.
But I don't know how much the complexity of inserting at a particular index, like at 0, and pushing all other lists towards the end. So that would be I think, uh, time complexity would be there because uh, I'm inserting at the first position and pushing all the other lists uh, back. So that would be an extra cost.
Okay.
So this two way, right? First, we can, first we can put it into an array. And when we have it, we reverse the array of
Yeah.
lists,
Yes.
right? The second way I think of is instead of have the array of lists, we can have like kind of a linked list. Okay, we have a linked list, and each element in the linked list, it is an array. So we yeah, so that if we in that way we can insert it. I mean, we can prepend to the linked list that take constant time.
Yeah, so that's one, like rather than taking a list, taking a linked list would be easy, so that you can insert at the first, like ahead of it would be easy,
Yeah.
and it would be order of one approach, like inserting
Okay.
it, inserting in a linked list at particular index. I think anyone
A
wants to.
little tricky to know, when you need to create a new linked list.
Sorry.
It's a little tricky, if we go that way to know when would you need to create a new linked list, right? Because if we go top down, we know at every level, then we can create a new one. But if we do reverse way, then it's a bit tricky, I think.
Using a reverse
Yeah.
logic. Okay.
No, I'm talking about we're using the linked list instead of an array.
Yeah,
right?
yeah, that would be a little bit tricky, but can be done. So one is like another approach would be, I'm thinking of using a stack while doing in an iterative way. Anyone has used stack solving this problem?
Stack would be similar to recursion, right?
Yeah, instead of doing a recursion, we are putting in a stack. Like
Explicitly.
while, yeah, that would be in an iterative using stack. Anyone wants to elaborate on this?
Yeah, with the stack, if you do recursion, I'm not sure if like you can quickly access the middle element, in the stack. Because with the stack, if you go do the recursion, then at each depth, we need to create a new array, right?
Yes.
Then it's not easy to access the middle element in the stack.
Yeah, that is one thing.
But I believe like that is true only when if we are doing if we are doing BFS, then the stack should work. Because doing the BFS, the current level is always on the top of the stack.
Yes.
BFS with the stack.
No, like we will do the BFS with the queue.
Okay.
Okay, but for each level, when we are storing the list for that level, we will put them in the stack.
Yeah, and when we are after that, when we have when we need to return our result, then we'll just pop out from the stack and just put it in a result in an array or a list and just return that. Is that a way you are saying?
Yeah, but wouldn't that be like an extra data structure we need to use, right? Because now we use an extra stack, versus that we already have an array to return.
But if we are saying that if we have a result while solving in a BFS, we'll be storing in a result, just reverse it. Which complexity is higher? Reversing it and then returning it, or just putting in a stack and then popping out and then returning it?
Reverse is constant time, right?
Reverse would be like,
Why reverse is constant time?
yeah, why?
Right, it's not constant time. I mean, it's big O of n, right? But
Yep.
yeah.
I think like if you put like in a linked list, that is fine. You can just insert it at the start.
I believe like
Okay.
where the trade-off like we are trying to look into is using extra memory versus like just reversing. Like if we have to use the stack, definitely like we are using extra memory. Okay, and then what we have to do, we have to again traverse the whole stack
Yeah.
by order of n to create a array list that we want to return. Okay,
Yes.
in the other way, like which is suggested by just using a list. Okay, put them in the order from top to bottom, and then reverse the elements in the same array. Okay, which will be we are not using any extra memory. Okay, and reversing the array is same as order of n as traversing the whole stack.
No, but I was telling like put in a linked list and always a bank in the start.
Yes, but again you have to traverse the whole
No,
list.
then I will always put my new result in the start.
Agree, but but see the result, like we are returning list.
Yeah, if I think I can. So linked list is inherited from list
Okay,
interface in
okay,
Java.
yeah, then it's a different case then.
I think so. It might work because like linked list is also inheriting from list interface. So then I don't need to like. I'm just throwing some ideas.
So you are saying inserting at always at a first would be order of n operation in a linked list, correct?
Yes. No. Inserting would be a constant time, like order of m1.
Oh, sorry. Yeah. Yeah, order of one. So
Yep, I just verified that in Java, linked list implements the list interface, so which is true, but
yeah.
this might not be true for like other programming languages.
I don't know. Because Python does not have anything like an array, list, or linked list. Everything is a linked list there.
List. Yeah, everything is a list in Python. So
And .NET, let me think. .NET also has something like similar.
I believe like we got multiple solutions. Why not like
Yeah.
try it out and we can move on to the next question?
yeah, we should move on the next question.